And welcome to week 9. We've got only a very small set of things to talk about today, but we got to go kind of in depth with these because it's a little intense. So, chapter 9 is dictionaries and sets, and we're going to talk about dictionaries and sets. They are basically new types of data objects that we will be working with. Dictionaries, I feel, are the more important ones, and when you start to see them as complex as they can seem, they are the foundation of a lot of data types that are currently on the internet today. And when I say, oh, they're on the internet, they're also part of online games. They're part of website data sets that you don't see under the hood. A lot of times for electronic commerce, that kind of stuff. So, a lot to get into. Then at the end, we'll talk about serializing objects with a fun new library. But let's start with a dictionary. What are dictionaries? A dictionary is basically an object that stores a collection of data. And a lot of people get these confused with lists or with tuples. There's a big difference though with them. So dictionaries are lists and tuples. They're kind of in an order. They're in a sequence, right? You have 0, 1, 2, 3, 4, 5, etc. A dictionary is what's called a hash. It contains a key and a value, and they always come in pairs like that too. Sometimes they call it a mapping of the key to the value, and so again, it's in pairs. So if you look here, what we have dictionary equals, key one, colon the value of key one, comma key two, colon the value of key two, and at first glance, aside from the use of the curly brackets, it would look a lot like a two-dimensional list, like we used with the coordinates x and y's, but they're a little different. But there's something to really consider as we start going through this, and the important thing here is lists and tuples are a sequence. Order matters. You can't just say, "Hey, I want the sixth item in this list," without actually having to iterate through it. You can say, "Oh, I want." You can grab the sixth item, right? But you need to actually know what number is what and where they all are. You can't just jump in and say here. I want the one that has this name associated with it. And I think that's what a dictionary gives you. It kind of gives you a name that's associated with it. I can say, hey, I have a dictionary full of scores, and I have, Jan had a 50 and Kyle had a 30 or whatever the case might be. And I can say, just give me Jan's score. And I can pull that right out of the dictionary and not know what order Jan was in that list. The other cool thing, dictionaries are mutable. And if you remember the phrase mutable and immutable, mutable means it can be changed, which makes our jobs a little easier and a lot more fun. So how do we do this? Well, you've got a variable name that's associated with a dictionary. So dictionary underscore name, bracket key. Oh, wait, I thought you said we had curly braces. We do have curly braces when we're defining it for the first time. When you want a specific value, you use that bracket notation, the square bracket notation. And basically that's how you'd grab an element out of this list. So, for example, if you say whatever key, it'll just return that value. You can also assign it to another value, right? Name equals, if you have a name as part of your thing, name equals dictionary name bracket and whatever key you want. And you'll see this in a second. I've got a great example. Things that raise exceptions: if the key doesn't exist, of course you're going to get an error. You can always use the test things as well too, so you can avoid getting one of those exception errors raised. So you can say if key name in dictionary or key name not in dictionary, where dictionary is your variable name. Those still work. We've seen that before with lists. So let's look at a practical example. What do you actually use these things for in the real world? Grab your phone, look up a contact in your phone list. Okay, this would be each contact would have its own set of dictionary style of values, if you will. So I mean, to just take this example, we have contact is the name of our dictionary file, and then it has a few values. What do you store in your phone? Well, you store somebody's name. You might store their phone number. It's kind of important for that, for texting and calling. Maybe you have their email address in there. Maybe you have your Twitter handle or their Snapchat or whatever, usually using the apps for that. But if you have that, you can click on your contact, click on whatever part of social media, and go right to that app's, to that person in that app if you needed to. So this is what your your dictionary would look like here, right? So if I wanted to get Jackie's phone number, I would say contact square bracket phone in quotes because it's a string, and it would return that phone number value to me. These are used on the internet in a lot of different places. This is the most simplest version. I think we've all signed up for a mailing list or logged in or created an account with something or filled out some kind of online form at some point in time, right? So if this was your web form and you have first name, last name, email address, and password just to sign up for a basic account, let's say, this would be on the back end of the person who programmed the back end of that sign up form. This is what they would have coming in. They'd have, maybe a variable called form fields, and that would have a name and value pair. So if you look, all our green keys line up with the form fields that are in that form: first name, last name, email, and password. And then the values associated with those after the colon in purple would be the values somebody may have typed in to that sign up form, if you will. So a lot of different applications of how these work. I've got a really complex one when we get a little more comfortable with this. But let's just talk about how we do things. So we have append functions for lists. Um, we have just a very simple variable key equals value. That's how you add something to your dictionaries. Conversely, and if the key already exists in the dictionary that you're adding it to, then the value that's associated with it will actually be overwritten. So you got to be careful that the key doesn't exist. Again, if key in your dictionary, then it'll return a true or false. If it's in there, you might want to choose a different key name. If it's not in there, then you're fine. You can just go and throw that value in. To delete something from a dictionary, del is the keyword, is the reserved word, if you will. Dictionary, and then key in parentheses. And again, if the key isn't in the dictionary, you're going to get a key error exception. Okay, all kinds of functions. You'll have all kinds of chance to practice with these in your lab next week. There is a len function that tells you how many elements are in the dictionary. That's by how many keys are there. Okay. Now, things to consider. Your key is immutable, meaning you can't have more than one key. You can't say I want to go to this variable and look for name, and then there'd be 3 names there, or phone, and there'd be 3 phones. Each one of the key values has to be unique and won't change. Okay, but the values of those keys that are associated with those keys, those can be changed. They are definitely mutable, and in fact, a value could be something different too. It can be almost any kind of data type in there. But yeah, we'll get there. We'll get there. Let's not get ahead of ourselves. Know that your keys have to be unique and they can't change, but the values of those keys can change. How do you create a new dictionary? Well, you just say variable equals 2 empty curly brackets, just like that. You can also use the built-in function called dict in parentheses to convert maybe a list to a dictionary, or use a for loop to generate items to iterate through there. Generally speaking, you'll probably set one up initially. If it's going to be blank and you're just going to be adding things to it, then you'll use the blank curly brackets. If not, you'll probably convert something down the road, but we'll figure out how that works shortly. There are methods. Remember, methods are they're functions, but they're functions called in that dot notation, right? So it would be some variable dot this function with the parentheses around it. So some of the functions, the methods that dictionaries have, there's a clear method. Basically deletes everything in a dictionary. It leaves it completely blank. It's almost like you've just said, hey, here's a new dictionary file. Okay. The get, it basically is kind of like addressing something by the square bracket notation. It gets whatever that key is, and it returns it to you. The cool thing is, if a key doesn't exist when you use the get method, there is a default key returned, so you don't get a key error, which is kind of one of the important parts. So if you don't know what's in a dictionary, although it'd be difficult to work with them, or if you don't know if a certain key exists or not, and for whatever reason, an if isn't going to cut it for you, then you can use this format, and that way, if it doesn't exist, you're not going to get an error that's going to crash and halt your program on you. A few more methods. Items, dictionary.items, whatever the variable name is, .items in parentheses. It will return all of the values in there. Each element comes out looking like a tuple, and its associated key value pairs in there as tuples. Let's actually look at some of these, shall we? Just kind of get going with this here. Bring this over here. Let's start with something. The book starts with a very interesting example. It starts with this phone book example here, and the phone book, you got 3 names and you've got phone numbers for them, right? So that's the format. Phone book equals curly bracket key of Chris colon and his phone number, and these are all strings here, comma to separate the elements. The next key is Joanne and her phone number, comma. The next key is Katie colon and her phone number. So if we tell Python to print the phone book, that's what it comes out printing it as. Okay, I can say things like if Chris in phone book. Actually, let's just do this. Chris in phone book comes back as true. But if I say Tom in phone book, that would come back as false. Okay, we've seen this before. You can use these with if statements. You can use them. Don't know how you'd use them with a while. I guess there could be a way of doing that. But here's your Boolean test, basically, in phone book. We could also say, let's see, Tom not in phone book. And we get a true on that one, right? We can say phone book dot items. And it shows us all the items associated with that. Or we could say phone book dot keys. This will show us just the keys that are in the dictionary sequence. Okay, and that's an interesting one. I can add. Let's add. Let's say phone book. What if I could just do this? I can say phone book Tom equals 555-3333. And again, I can come over here and say phone book keys, and now I see Tom is in there. I can say phone book Tom, and remember these are strings and our keys at this point, and they don't have to be. They can be other things, but strings are very common actually for something like this, and it gives me like the value for that, right? So yeah, some of the different things we can do. So there's items. We can also use keys. Pop is an interesting one. If you pop something off, it actually removes it completely if it's found, if the key is found. So here's an interesting one. I could say Tom equals phone book dot pop Tom. And what that will do was we'll take Tom out of the phone book dictionary and assign the value of it to my variable Tom here. So I can say print Tom and get that value. But now if I say phonebook.keys, Tom is now gone because we deleted Tom, but pop is a special case version of delete. So if we say pop a certain key off, we can assign that. It actually returns the value. And we can do with that as we need to. Think about, I'll go back to a video game example since I like them so much. Think about if you're going to use a one-time use item. For example, maybe you have a health kit in your character. You would pop the health kit out of the dictionary that was your item inventory, and then you would assign it to a variable temporarily that would do whatever it was going to do with your health or whatever like that. So that's pop. There's a very similar one, pop item, that will just take basically randomly selected key value pairs and just kind of plops that whole thing from the dictionary. And values returns all the values. kind of the opposite of keys. It gives you the values without the keys. So there you are. Some dictionary methods that are there. Know these. You're going to have to practice them in the lab next week. I've kind of glossed over a lot of this, but I want to show you something. Really kind of want to go over a few little things here in how much we can get in this. So let's try this here. We don't necessarily need to put one value in a dictionary. We can actually do quite a bit of things. One of the items that I've seen, I think this example is also in your book, is a bunch of test scores. So what we have here is a dictionary named test scores, and we have our name value pairs. Name, the key here is Kyla, colon, and the value is a list of 3 scores. Then we have Sophie, and her value is another list. Ethan, his value is a list, and Lewis is a list as well. So we have 4 keys, and again, I can say test scores dot keys, and we see the 4 keys. I can say test scores dot values, and I can see the values. So what we can end up doing then is we could say something like, let's do this. Let's start off with this new thing here. Okay. And I can say for person in test scores, and then we can say, let's just start with something simple here. Print person. We'll format this up a little bit. And then we'll say print test scores person. Now, that looks a bit weird, but let's see what we're doing here. For each person in test scores, what we're saying here is for each key in test scores, that will start with Kyla, go to Sophie, Ethan, Lewis. Okay? We're going to print that key, put a colon in a tab, and then we're going to print the value of that key. So test scores, this. Okay? And again, let's just, while I'm here, if I say test scores Kayla, and if I spell that with a capital K, because it's a string, case matters, it will print that out. That's a list. Okay? That's what we're going to get for each one of these. We're going to iterate through and say print the person, the key in this case, and then print the value of that key from person. For each key inside of test scores, print the key and print the value of the key. Let me run this. Let's just do that. And my tabs are a little off here. Sophie's name is a little long, but you get the idea. And again, let me just leave the code up here with the output. Okay. Bring that up a little higher so we can all see it. Okay, so we have our test scores in a dictionary, and then a very simple for loop to iterate through it. It doesn't matter that these are lists. We can still print out a list, and we see how those look. Well, let's get a little more fun here. Let's get really in the weeds. I said a dictionary value can be any data type that we know. And that's kind of an important part to consider. Because I can have a dictionary of 3 elements here. And those elements could have dictionaries as the values to go in each key. I'm going to copy this as it is. And we're just going to paste it into here so you can see. So I can say grades dot items. Let's do grades dot keys. Okay. And those are my 3 keys. Alex, Taylor, and Jan. As in 3 students in some class somewhere. Right? And then I can say grades dot values. Now the values of each one of those keys is itself a dictionary. And as you see, we get several dictionaries back as our values. Because Alex's value is a dictionary with 2 keys, tests and labs, and the values of each one of those keys are lists of different sizes, 3 tests and 5 labs. So this would kind of be like your grades in this course right now. We have tests, we have labs, okay? And I've said before, the keys and values, the thing with a dictionary is that they're not ordered. You can just say, hey, I want Taylor's lab scores. And the labs are in a list, which are ordered, which is fine because we have lab 1, 2, 3, 4, 5, etc. down the row. I'll just take them and I can use a for loop to iterate through those, no problem, because effectively they're the same numbers. Technically, a list starts with 0 and goes up to the number of elements in the list minus 1, but I can add 1 for the human readability when I'm making a report. So we get this really complex looking thing here. But you'll get the idea. Alex, and we just have a nested inside a nested inside a nested here, right? So I have for name in grades, and we have 3 names. Those names would be Alex, Taylor, and Jan. I'm going to print grade report for the name, and then I'm going to start a counter. And this is a shortcut. I know we've seen this notation before. I could say counter equals 0, average equals 0, or I can just say counter, comma, average equals 0, comma, 0, and just assign them both at the same time, for those of you who are confused by that notation. And then I have a new loop here, okay? And just give some spacing here just so we can get it all cleared up. I have for grade in grades. Now, what am I doing here? Now, and look at this notation with the double square brackets. Where is this coming from? Well, for name in grades, we're going to get Alex the first time through. I'm just going to start with the first key. So we'll print name, which is Alex in this case. Now we're going to say for grade in grades name, and then tests, because the key of tests. So let's think about what's going on here. We have, I want a grade from this, which is going to represent Alex this first time through. And what part of Alex do I want? Well, first I want tests, and then I'm going to iterate the 3 things in there because that in and of itself is a list. And then I'm going to do the same thing again down here. Grades name, the first time through again will be Alex. The next time through will be labs, the second key in this dictionary. And yes, is this really convoluted? Absolutely. Is this normal in the real world? Yeah, actually it is. This is what's going to take your programming to the next level. I talked about how, in fact, I've had a lot of one-on-one meetings with some of you, and I've talked about how some of the examples that we do in the labs are a little simplistic. This is a little closer to real world. There's a type of data called JSON, JSON, and it's very, very similar to what a Python dictionary is. They were developed completely separately, similar but not, but this is what a lot of data sets can, in fact, look like. And multiple things are in square bracket notation, and the whole thing is in these curly bracket notations. And when you start another set of things inside a thing, dictionaries inside dictionaries, you get multiple sets of curly brackets. So, what is this going to do? This is going to print us a grade report. It's going to start off with this fancy little header, grade report colon for the person. That's our first key in grades. It's going to come through and find the first person's first element in this nested dictionary called tests. Iterate through it. We're going to have a counter. We're going to have an average aggregator. It's going to add the grade, each one of these. So the first time in through is going to be 93, then 92, then 94. We're going to print test counter, which would be test 1, colon, the grade, tab. Keep it all in one line. When we go through again, it'll be press 2, test 3. When we're all done, we'll print out the test average. Then we're going to come down here, reset our counter and average variables, and run through another for loop, passing it this. Wait a minute, we're doing the same loop. Can't we put this in a function? Yes, absolutely, and it should be. These loops are effectively the same thing. Test here, tests here could technically be the same. You could pass the same value in there and let it be. You wouldn't have the plural, but you could pass in a function that says, hey, pass in this, and then iterate through all the things inside that. Let's not get too overwhelming. This is already kind of complex. So again, our first element of Alex, the value is a dictionary in and of itself. So the first dictionary, we're going to go through the list that's in there. The second item in that dictionary, we're going to go through the list that's in here. When we're all done, we're going to print a few blank lines and start this loop all over again with Taylor. Let's see how this runs. Did I change something? I did not mean to change something if I did. Oh yeah, I just threw some spaces in there for readability. That's fine. And over here in the wrong window, I'll drag it over. This is what we got. We have grade report Alex, test 1, test 2, test 3, test average. Lab 1, lab 2, lab 3, lab 4, lab 5. Lab average. We have our blank lines here. Let's find our code window so I can throw it off to the side here so you can all see it. Best we can. Yeah, you get the idea. Okay, this is complicated. This is not uncommon though. And this is something you should all be aware of and know how to do. If you really break this down, there is nothing we haven't covered here before. It's for loops, iterating through items in something. In this case, both in a dictionary and in a list. That's really all it is. I would expect that everybody can do this part of it. Iterate through a regular list at this point. Lists were 2 weeks ago. Iterating through a for loop was week 3. Week 4. That should not be a problem. Okay? It's just a matter of building on everything we've done and seeing how they all come together to make something rather large, actually. So be aware of this. This is how, and this is going to be expected. Come Project 3, you should be knowing how to do something almost identical to this. That's not a hint. This is not what your project is going to be. But you should know this level of how to do. I will repeat what I've said to many of you in all kinds of meetings, in all kinds of emails, in the announcements. If you need a catch-up session, we're going to have a whole bunch of them coming soon. If you need something more one-on-one, please don't hesitate. Reach out. It's tough with online class and having to do a video like this and not being in the room to see nodding heads or confused faces. So we want to definitely make sure that if you need help, email. Just reach out. We'll get it to you. And we'll go through this again. You can always watch these videos again until you get it right. This with the book should be a good start for what we need to do. All right, so dictionary methods, things that we're considering and we're concerned with. Make sure you have all these methods, and that's what I got for dictionaries at this point. Next, we'll move on to sets. Okay, so moving on. Sets. What are sets? Sets are kind of like mini lists. We're going to go from something really complex, like a dictionary, down to something just kind of that we should know already. Think back to math class, right? A set is basically another data type. It stores a collection of data, just like a mathematical set. The difference with sets is you can't have repeated values. Everything inside a set has to be unique. Like a list or a tuple. Unlike a list or a tuple, sets are unordered. So take the order, jumble them all up, and all it does is take out the uniques. Interesting thing too, sets can have elements of different data types. So where a list or a tuple has to be all strings or all ints or all floats, both sets and dictionaries, the elements can be very different data types. So how do you create a set? Well, there's a set function. Something equals set. So basically, you might have a list name. List name equals set, right? Let's pull this up and try this out here. So if I have my list and it equals, let's just say A, B, C, D. And let's say we have another D and another A, or an S, that's fine, and another A and another B, and there's my list. Okay. And I can say, print my list, it looks like that. Then I can say my set equals set my list. Okay? Basically cast my list into a set. And now, if I look at my set, it only has the elements that it's only one version of each element. So B was repeated in there, C was not repeated, S was not repeated, that A was repeated, the D was repeated, okay? But that's what it gave me, and it's certainly not in any semblance of any order, right? So the argument you give it can be pretty much anything. It can be a list, a string, or a tuple. I can actually do this, and I could say, state equals set, and I could say Mississippi, Mississippi. It's the only state I can think of that has that many repeated letters. And if I just show state, there's a lot of repeated letters in the word Mississippi, but that's what I get. And as you see, if you give set a string as an argument, it will still break it down to the individual characters. Because remember, strings we said were sequences in last week's lab. So Python sets are just really useful to very efficiently remove duplicate values from some other sequence or collection of some kind. And then you can do all kinds of different things like unions and intersections. Remember those from math class? We'll get to there. You will remember it. But that's what a set does. It basically just takes whatever item you had, any sequence that you had, and takes all the uniques only. Okay? So use the set function to create a set. We have len, we have add, we have update. I can do, hello, I did not want to do that. We can have, I could say len of state, it's 4. I can say len of my set. We know there's 5 things in there. I can say, and these are methods actually too. So I could actually say my set.len. No, I can't. These are not methods, these are functions. But we can add an update down the road here. We will. The argument that you set, the argument that you give has to be a sequence. Pretty much the same thing. Anything that's iterable. And the elements are added to a set. We do have elements, we have functions for removing elements from a set. There's remove and discard, both of which take something out. But when you use remove, the value that you're removing out can be passed back into a variable. Okay, much like pop when we had for dictionaries. Discard just removes it completely. Again, remove would do a key error exception. Discard does not raise. Sorry, have it backwards. Remove will remove things. Discard will pass it back. Remove raises a key error exception if the element isn't there. Discard does not raise an exception. Clear, just like a dictionary clear method, will clear everything in the set and make it an empty set then. Just like any other sequence we've talked about, you can use a for loop to iterate everything through it. For item in set, do something with each one of the letters or elements that are in that set. You can still do in, something in, if some value is in your set, some value not in your set, those work the same way. Then, now it's time to think back to high school math with sets, and we had unions, and we had intersections. So the union of sets basically is something that contains both elements. And I think I have an S in here. I do. So one more time, we'll say, nope, my set, and we'll say state. Now, if we wanted to see a set that contained all the elements, I could say set1 union. Nope, not set1. Let's say my set union state. What this will do is it'll say, okay, find all the elements in both sets and give that to me. So I think it's just the S in this case. Nope, this is the union. This is going to join them both together. So it kind of adds it at the end. Now, we still have our individual sets by themselves. I could say new set, or I can say union for that matter. Let's say my union just to make it nice. My union equals my set dot union state. Again, I still have my set, I still have state, and now I have my union, which is all of them. And again, the order is not necessarily what you may have thought. Okay? Then there's intersection. We can say my set dot intersection state, and again here, this is where it'll only be the S, and that's what we get back is just the S. I don't recall if unions and intersections and sets were part of Math 220. If any of you have taken that yet, it's been a long time since I took Math 220. But again, think back to like your sequences of math. If you're all New York State residents, you took Math 1, 2, and 3. I think this was in Math 2. I think it was also in like middle school math as well at one point. But again, union is finding the elements that are in both sets. Intersection is essentially, union is things that combine both sets. The intersection is the things that are only found in both sets. There are ampersand and pipe characters here for this if you want to use those instead of intersection and union. Code is more readable using the methods of union and intersection, but for your own personal edification, you can certainly use the pipe or the ampersand there. The difference of sets, you can actually say set 1 minus set 2, so we can say my set minus, my set minus state, and that's what the difference is between those. It's also difference, so my set dot difference set 2, no, state, sorry, be all right. Get the same result. Then there's one called symmetric difference, and symmetric difference is basically a set that actually has the elements that are not shared by the two sets. So in our case, and I'm going to use the shortcut here, which is the caret. So I'll say my set symmetric difference state, and that's actually a longer set of things that are not. So it's kind of like the inverse of the difference, basically. So I guess the last things with sets, there's is subset and is superset. Subset being if all the elements in A are also included in set B, then set B is a subset of A, right? Other way around, set A is a superset of B if it has whatever it has and everything it has is also all the elements in B too. And you can use the is superset method to determine whether A is a superset of B. So you've got subset if all the elements in A are also included in B, and superset if all the elements if B contains all the elements, if A contains all the elements of B too. So those are your sets. Really the practical version of using sets. Again, finding things that are similar or finding things that are just the difference in between, again, two sets, but that could be lists or strings or words for that matter. Another way of doing it. All right, the last thing we're going to cover today is something called serialization. Serialization is basically when you convert something into a string of bytes. Now, remember we talked about this. In fact, there was a question on exam one about how data was stored. And we said uh, anything that was a string or anything that was not a character was characters were stored as ASCII. Everything else was pretty much stored as binary. An object can be serialized and converted into basically a stream of bytes, which get a little more compressed the way they are stored. And it's a really quick and dirty way of making data really, really small. And so are dictionaries for that matter, too. If you're just passing objects back and forth, then you can take a dictionary and serialize it to make it even smaller in terms of size on disk or size in memory. This makes transporting this data more efficient. And if you think about, I'll be honest, one of the games that I love to play on my phone is Clash Royale. And if you're not familiar with it, it's basically a network game. You play against one other player. You all have similar characters that the game knows about, and you drop them onto the stage, and they go attack the other side of the board. And the thing with that is, you drop your character down, and it sends data to the other player. Again, over your cell phone network. So the data it's sending can't be really huge. It's not sending every single move that character makes. It's saying, at this second during the game process, the first player dropped character XYZ onto the board at coordinates X and Y. The person's phone on the other end who's running the same game knows what character XYZ is, knows how fast it moves and what attacks it has and how it does things. And all it has to know is when the character got dropped, at what time, and at what coordinate point. That's all it needs. That can be serialized really small and sent across the phone network so that there's very little lag when you're playing games like that. A lot of other games work similarly too. You're playing any MMO, if you're playing, Overwatch or Call of Duty, right? That kind of stuff. Fortnite, any of those massively multiplayer, games. You're not you're not telling every time you make a turn, every time you stop or start or accelerate or decelerate, that's when the data gets sent across. It's not every single frame of action that your character does that gets sent across the network. That would be horribly inefficient. And then when they're doing this, they serialize the data packets so they're smaller. And they're very quickly able to become unserialized to break them apart and reusable again on the other end. So that's one main way that you would serialize some data, especially when network resources or disk resources can be scarce. So in Python, we get to work with something called pickle. Pickling. If you pickle something, you are serializing some kind of data object. And yep, it's funny. It's just what the powers that be decided to call it when they created it. So to pickle an object, which is what you call us when you serialize something in Python. I don't think any snakes that I'm aware of like pickles, but hey, who knows? To pickle an object, you import the pickle module, and then you use pickle.dump, which sounds like a bad traffic accident from a farmer's warehouse. But you open a file, you call the pickle dump function, and then you close the file because pickles are objects that are stored on disk. So they are definitely files, the same way we do open and close for any other file that we're writing, only this is a special kind of file format. You can actually pickle multiple objects in one file before you actually close it. So you can have several pickled data objects inside one file. Okay, and again, that file then becomes transported across wherever. Okay. Conversely, to unpickle something, you still use the pickle module. You do pickle.load instead of pickle.dump. You still have to open and close the file on both ends, right? So let's see what this looks like. Let's get this, but so I had this data set. I think it's still in here. Nope. But if you recall, we had this data set called grades, and it was a fairly large, fairly complex dictionary. It was a dictionary of dictionaries, And the nested inside dictionary was a dictionary of 2 elements. The values of each were lists. Okay, very simply. Let's do this. Let's save this to a new folder. Okay. And what we will do here is we'll say import pickle. We've got our grades data. I'm not going to do anything with this. All I'm going to do is basically serialize it out. So we have our pickle out file object equals open grades.pickle for writing. Wait, what's WB? When you write a file, you just simply write it as a stream. You remember we wrote things as strings. Things were converted into ASCII, and we had to put a new line at the end of each one. Pickle does not use regular ASCII characters. It's using binary data, which, if you print it out, kind of looks similar, but it's not. And it's certainly ones and zeros that are kind of Unicode, but not really. A text editor will try to interpret it as Unicode, but again, it still isn't. So this extra character here says write as a byte file. Basically write as binary byte data. Okay, then we call pickle dump. What are we passing it? We're passing it grades, which is our data object, and we're passing it the file handle that we want here. Okay, and then we're saying pickle out, which is our file handle here, dot close, the method to close it up. Plain and simple. I'm going to run this. It runs. It looks like nothing happened. So let's do this. Let's well, I guess if I moved my file window over, you might see it. Okay. Okay, extra large might not necessarily be in order here, but we have, let's just say list. We have grades.pickle and we have pickle.test. So pickle.test is my program. Grades.pickle. Windows is asking me, what is a pickle file? How do I want to open it? I'm going to show you in Notepad what it looks like. And you can see it's trying to get some of the data that's in there. You can kind of see something that looks like Alex and tests and labs and almost Kyle and Taylor and Jan, and that's about it. Everything else just looks like a bunch of gobbledygook because it's binary data. It is not Unicode. It is not it is not ASCII. It is not Unicode. Okay, it's not strings. It's binary data, and as you see, it's still very, very, very small as a file. But that's it. The pickle file can be used just to transport data, large amounts of data. Like if I can do. I'm gonna mess this up trying to do this on the fly, aren't I? These have to be unique, so we'll say Alex2, Taylor2, and Jan2. Sure, we'll save it. Then we'll run it. And our pickle file is still, even though we've doubled the size of the data that we have here, it's still 1K in size. All right, now I'm going to leave that there. We have 6 elements in our grades now, right? And it's saved as a pickle file. There's my depickler. So I have the same program I had before. Can show it to you if I still have it here. I do. So before, I actually had grades on line 1 here with the 3 elements, and then my big giant loop. And as you can see, if I put these on the same lines, they're still pretty much the same right there. Okay, the same for loops, same everything. The only difference with this file here is I am now reading in that pickle file, and I'm using that to load my grades dictionary. Now, again, the difference. This grades is 3 elements, where the grades in this pickle file that I did are going to be the 6 elements that I had before here. Okay? So now let's just see. And one thing I want to call out real fast as well, And actually, this is saved in the wrong folder, so let me save this as into my temp folder here. All right. There it is. Let's just open it from here just to make sure we're looking in the right folder. And I know that by looking at my right above these lines here, in my title bar here, it says desktop temp pickle. Okay, we know exactly what folder it's in my title bar, right up in here. Okay, we're going to import pickle. We are going to open the grades file, and again, we're opening it for read, but again, we're telling the open command, when you open this file, read it as byte data. Don't read it as some kind of textual ASCII string data with new lines. Okay? And that B is very important. How important is it? You know darn well it's going to be a test question. You know, if you see R or if you see RB, what are you going to be reading in? Okay? But the data types are very, very different, and you will get exception errors if you try to read it indifferently. I'll show you that shortly. So, pickling, something very short, that's something very simple, that's taking a lot longer. In file, open the file for read bytes. Grades equals, hey, just pickle load from that in file. From this file right here that we made, just load the information out of pickle. Then close the file up. Then we'll work with grades. What we should get is the same output we saw before, actually only with 6 elements now instead of 3, we'll have 6 elements. Read in from our pickle file. And there it goes in the wrong window. But look what we got here. It certainly ran. And if you want to just see me run it one more time, just for laughs and grins, so it's all on the same screen, there it goes. So, our grade report. And again, we loaded this from this pickle file. Okay? Here's Alex, Taylor, Jan, Alex 2, Taylor 2, and Jan 2. Now, what happens if we don't read this as a byte file? What happens if we only read it as just a regular plain old file? I will save this, I will run it, and you will see our major error here of type error. Must have read into, or read line attributes. And this file does not because it's a byte file. Pickle files are binary data. And that is the biggest thing to remember with pickles. Save this, run it again after adding that B, and you see it works just fine. So that's serializing things. That is what it means to serialize something, at least in Python here with pickle. A lot of developers love pickle. If you, the one caveat with pickle is when you read it, you don't actually know what's in it. Why is that a big deal? If someone decides to write a data object into a pickle, and as the data unpacks itself, it spews code into your code, people could write malicious things, store it into a pickle, and throw you a virus, crash your machine, crawl your network. Pretty much whatever they know how to do in code, they can probably do. So you want to be careful, and you need to trust where your pickles are coming from. The Python people absolutely know that this is a major issue, a major security hole, if you will. So you take a loaded statement, you've got to trust who you're getting your pickles from when you load pickles from essentially unknown sources. Think about Word. When you download any file from the internet, whether it's Blackboard or somebody emailed you something and you open that Word file, if you're using Windows especially, they know the newer version of the Mac Word does it too, it'll tell you, hey, this is open from the internet, I'm opening this in read-only mode, I don't want any macros to run or anything else to happen because we just don't know what people will do inside files. That's essentially what we're talking about here. A pickle will do the same thing. So if you unpack a pickle from an unknown source, just be careful and do it in some kind of environment that there's no internet connection, there's no anything else, and it's a machine that you might want to potentially destroy. That harboring of bad news, what did we cover this week? It was actually a lot longer than it should have been, but I hope we dove deep enough into it. We did dictionaries, creating dictionaries, iterating through them, what they are, what they're used for. And again, they're used for a variety of different things. And they're very similar to JSON objects that you might find on the internet. We talked about sets. Sets are elements to basically help you find things that are similar, things that are different. Once you have a set, you can also look at unions and intersections and subsets and supersets and all that stuff. And then serializing objects, basically using the pickle method of pickling and unpickling your objects. Again, and why do you use those? It takes very large, complicated data sets and makes them very small and tiny as a binary file that you can send back and forth across the net, back and forth across a network, through different TCP packets, that kind of stuff. If you throw some encryption in there on top of it, now you've got a secure, very small messaging kind of thing you can do back and forth across a network connection if you wanted to go that route. It's very much useful for taking large chunks of data and data objects, making them small and portable. And that's the summary of what's going on. If you need extra help, please check out the discussion forums, send emails, certainly set up appointments or come to office hours. Very soon in the coming weeks, we're going to have more open sessions. I'm going to try to do some live sessions. We'll send a survey out to see when people might want to do that. Thanks for watching and have a great week.